Welcome back, everyone, to this section on tokens, OpenAI models, and model pricing. There's no time to waste, so let's kick things off by discussing tokens. You've likely used ChatGPT and know it works by sending a prompt to the model and expecting a text answer. The question is, how does the model make sense of this text? How does it understand the meaning of the words and their mutual connection? How is it able to devise a response? This, of course, is a challenging question to answer. But in this lesson, we'll look at one aspect that makes this possible: tokenization. Tokenization is a process whereby text inputs and outputs are broken down into sequences of characters called tokens. The unique tokens that an LLM operates form the vocabulary of this LLM. A token amounts to roughly 3/4 of a word. An easier way of remembering this is to consider that 100 tokens corresponds to approximately 75 words. So when talking about OpenAI's tokenizing mechanism, a token isn't necessarily a single character or a word, but rather a sequence of characters frequently seen together. The task of a language model is to understand the statistical relationship between the tokens in its vocabulary. Once it does so, it can predict the token that is statistically most likely to occur next in a sentence. It then does so with the next token and the next, ending up with a text completion model. Cool. You might think that this definition of a token as roughly 3/4 of a word might seem a bit arbitrary. Why not define tokens as short as a character or as long as a phrase? Well, of course, it's a trade-off. Surely, making the tokens smaller reduces your vocabulary, which in turn makes the model more memory efficient. Additionally, smaller tokens allow for a more agile model that learns new words and languages more easily. Still, this could make it harder for the model to capture the semantic meaning of texts. As you can imagine, predicting the next word in a sentence is easier than predicting the next character. On the contrary, larger tokens could provide better context, but this comes at the cost of increased vocabulary size. Imagine we defined a token roughly as a sentence rather than a word. This means that even the slightest modifications to this sentence would result in different tokens. Again, it's easy to imagine that predicting the next word in a sentence is much easier than predicting the next sentence in a paragraph. So the sweet spot of token sizes is somewhere in the middle. Okay, I think it's time we open OpenAI's tokenizer platform and demonstrate the nuances of tokenization. Let me first briefly walk you through the website using OpenAI's example text. We have an input field where we can enter the text to tokenize. Since different OpenAI models use different tokenizers, we can choose from several options. Next, we have a counter on the number of tokens and the number of characters in the text. Finally, in the bottom field, we can see the text split into individual tokens. We can toggle this to see the text as a list of token IDs as well. This is useful for identifying identical tokens within a piece of text. All right, let's also study the short text from the example provided. The first sentence informs that words frequently map to a single token. But this isn't always true, as seen by the words indivisible and sequences. Next, we explore how tokenization processes emojis by splitting them into multiple byte-based tokens. The final sentence informs that characters commonly found next to each other may be grouped, such as a group of 3 consecutive numbers. Okay, let's now test this tokenizer with a couple of sentences. Pay closer attention to the word "what" in the following. What would you like to have for dinner? The word "what" comprises an entire token with the following ID. A space does not precede the word and starts with a capital letter, indicating that it sits at the beginning of the sentence, which is likely a question. Additionally, the question mark is a token on its own, with an ID of 30. This is a commonly occurring token, therefore it has a lower ID number. All right, let's try another one. I don't mind what we have for dinner. Here, the token containing the word what, in lowercase, includes a preceding space. This indicates that the word sits in the middle of the sentence, likely a statement. As a result, the ID of this token is different from that of the previous sentence. Let's now try one final sentence. Have you listened to What a Wonderful World by Louis Armstrong? Here, the word what starts with a capital letter and is preceded by a single space inside the token. This indicates that the token likely sits in the middle of the sentence and is part of a name or a title. Again, the ID of this what token differs from the IDs of the first and second one. Okay, I hope you now have a good understanding of what tokens are. In the next lesson, we'll use this knowledge to discuss different OpenAI models, their context window limits, and different pricing points. See you shortly.